Hello everyone, welcome back to our channel. Today we are going to dive into a new problem, that is wildcard string matching. So let's see the problem statement. Our task is to determine if two strings that are given as an input, wild and pattern, can be matched or not. The wild string may contain special characters like a star and a question mark. This star can be replaced by a sequence of character, while this question mark can be replaced by any one character. So we will see an example to understand this, and we will decide what is the best approach for this problem. So let us take a small example. Let's say this is our wildcard string, and let's take another string which is our pattern string. So we have to check if we can reduce this exact string from our wildcard string or not. So for that, what we can do is we can create a DP matrix, and the size of the matrix will be m plus 1 cross n plus 1. So here m is the length of the wildcard string and n is the length of our pattern string. So let's create the array. So m is So n will be 3 plus 1, that is 4. So we have created 4 columns, and our m is 4, then we have to create 5 rows. So let's create 5 rows. Yeah. Now let's say we have an empty string in our wild string and empty string in our pattern string as well. So in this case it will always return true because both the string are blank. So we will store true in this index. Now what we will do is we will start iterating in both of the string and compare each of these character at our wildcard string with each and every character in our pattern string. So at first time A will be compared with A, B and C. Accordingly, we will store our result in this array. So let's do a quick dry run and check whether it is giving right or not. So we will start our iteration from the first index of both the string, and we will compare whether the previous character of both the strings are same or not. So we are starting from 1, 1. So we will update the value for this index. So and our previous characters are A in pattern string and A in the wildcard string. So both are equal, right? So we will simply update it by true. Now our pointer in the pattern string will increase by 1, and then we will check the previous character of our pattern string, that is B, is equals to the previous character of our wildcard string or not. So that was A. A is not equals to B, then we will add false in this position. This is our 1, 2 index. After updating the value in the matrix, we will increase our pointer. Now our pointer will points to this character in our wildcard string. But we will check our previous character of the wildcard string to the previous character of a given pattern string. So A is not equals to B. So in this index we will return false. Then again our pointer will increase. We will compare the previous character, which is C, with A. So those are so that is not equal. A is not equals to C. We will store F, means false. So by now we can see that we have compared all the elements of our pattern string with the first character of our wildcard string. Now it's time to increase the pointer to the next character in our wildcard string. So our pointer is pointing to this character. We have to compare the value of the previous character with each of the character in the pattern string. So let us do that quickly. B will be compared with A and it will return false. B will be compared with B, which will return true. Then B will be compared with C. This will again return false. So far we have compared this character B, with every characters in our pattern string. So now it's time to increase our pointer again. Our pointer will points to C and the previous character is star. We will compare this star with each character in our given pattern string. So at first star is compared with A. Now in case when we got star, so it is a special case. In this we have to consider 2 points. Here we can go one step back in our wildcard string. So currently we are at C. We can go to star and check whether it is equal to the current character of our pattern string. So it will be same. Or what we can do is, here we will not update the I, but we will go one step back in our pattern character. Or what we can do is, we will remain in the same index of our wildcard string, but we will go one step back in our pattern string. By this we can check the corresponding characters are equal or not. According to our example, we are currently at C. We will go one step back. We will get a star. And we will compare this star with the current character. We will not change the index in our pattern string. So we will check whether these two are equal or not. So this is not equal, and we will also check the second case where we will keep our pointer in C same. So we will get C and we will go one step back in our pattern string. So j minus 1 will be A. So we will check if this is equal or not. So they both are false. So in this index we will return false. In the next iteration our pointer will come at C. Now we will check the previous index of the pattern string with the previous index of our wildcard string. That is what we are doing till now. So we will see that star and B is being compared. So again this case appears. What we have to do, let's see it again. We have to go one step back in our wildcard string. So currently we are at C. We were at C. We will go one step back. We will get star, and I will compare it with the current character, which is B in our pattern string. So this two will be compared. This is not equal, so it will return false. And the second case was, we will keep our iterator same in a wildcard string and decrease our index of our pattern string by 1. So we will point to A this time. So let's compare C and A. These two are also not matching. So we will return false from here. Let's write false. And in our final iteration, we will reach to this index where it is a blank, but we have to check the previous index value with the star. So again that special case arises. So again the special case arises where we got a star and C. Now if we see, we will take the previous index, that is star. Star will be compared with the current index, that is a blank in our case. So star and blank is not equal, it will return false. But in the second case, if we see, star will be compared with C. We will decrease one step in our pattern string also, so star will be compared with C. These two are also false. We will return false here. Now we have to perform our last iteration, where I will be pointing to a blank character, but we have to compare the previous character with all the characters of our pattern string. So C will be compared with A. Let's do it fast. C will be compared with A, which will give false. C will be compared with B, which will give false, and C will be compared with C. Now we got true. So we will return this index, whatever the value it will be storing. So in this case we are getting true. So our answer is yes, we can deduce ABC from this wildcard, from the given wildcard. This is how we will approach to this problem. And by the way, when we initiate our DP matrix, it will store false in every character. So all these character will be false. At last, after all the iteration, we have to return the value of the last index that will be storing our result. So I think we are clear with the logic. This problem, the time complexity will be m cross n, because each character of our wildcard string is compared with each character of our pattern string. So it will be m cross n, and the space complexity will be also m cross n. The reason behind it is we are creating a matrix, DP matrix of m plus 1 cross n plus 1 size, where m is the length of the wildcard string and n is the length of our pattern string. So now let's dive into the code and implement the logic. So let's take two variables, m, which will store the length of wildcard string or GTH, and let's take n, which will store the length of our pattern string dot length. Now to store our result, we have created a DP matrix, so let's create it, and the type was boolean. Boolean dp equals to new boolean, and the size of the matrix was m plus 1 rows and n plus 1 columns. Now our base case was when our string was empty. So in the 0th position, we will by default keep true. So when our string is empty, we can say that both our wildcard string and the pattern string is by default equal. Now we will have to fill our DP array. So we will start our iteration from the first index of our wildcard string till m, and it will increase by 1. In the second loop, in our loop, we will iterate every characters in our pattern string. It will also start with the first index less than the size of n, and we will increase it by 1. Now we will check if the previous index character of a wildcard is equal to the previous index character of our given pattern string. So how we will do that? Wild dot caret I minus 1 is equals to PATTERN dot char at j minus 1 or not. If the previous characters are equal, then we will consider it as a match. Here we will also add one point that if a character in a wildcard is a question mark, then it will be replaced. Then it will be replaced by any of the character. So for that we can add a condition that if wildcard character at ith index is equals to a question mark, in both cases we will return true. In the dpth I comma jth index, we will simply return true. So how we will return true? We have stored true in our first index. So we are already having a value in our zeroth column, zeroth row, zeroth column. We will copy the value in our current column, and we will copy the value in the current row, current column, that is I minus 1, dp of I minus 1 and j minus 1 was true, so it will be copied to the current row and current column if this condition is satisfied. And if there was also a condition we have discussed when the character in the wildcard is asterisk. So let's check if the wild dot caret I is equals to a asterisk. In this condition, we were in this condition we were tackling two situations. Once we were going backwards in our wildcard and keeping the index of our pattern string same, and in another case we are decreasing our index in our pattern string and keeping the wildcard index same. So let's quickly do that. In dp current row and column, we will add dp's I minus 1 index. We will decrease the index of pattern string, or what we can do is we will keep the index of pattern string same and we will decrease j by minus 1. So I hope this logic is clear. This will tackle the situation when we will encountering a asterisk in our wildcard string. And now when we are done with this, we will return the final value at our last index of our dp matrix. That is what we have done, right? So this was a part of code which will tackle the situation when there is a match. But what if the wildcard characters are exhausted and we are still left with our pattern string? So what we will do that? So let's write the condition, then I can explain it also. So for that we can run a loop. Our loop will start from the first index of our wildcard string. It will go up to the length of the wildcard string that is stored in M, and we will increase it by 1. And now we will check if the previous character of the wildcard caret I minus 1, if the previous character is equals to the asterisk, means we have encountered any asterisks or not. So it will be replaced by rest of the characters which are left in our pattern string. So that is what we are checking here, and we will also check the empty string is true or not. So is what we have stored in our first index. So 0 comma j minus 1. If this condition is true, we will update our current index of dp matrix, that is 0 comma j, with true. So I hope this logic is clear. It's just that when all the character in our wildcard is exhausted and still we have some of the characters left in our pattern string, then in that case we will check whether we have any asterisks in our wild character, and if it is there, it is easily replaced by the rest of the part in our given string. So now we are done with our final code. Let's check if there is any issues. We have taken our dp matrix, dp default value is the base case is true. We have started a loop till I. Okay, the previous index will be I minus 1, and we will store in the true in the current index. So this is quite a bit modification. Here it will iterate till m, and j will iterate till the length of the pattern. Yes, it is right. We will check whether the while is equals to question mark, or then it is a match, else we will take that two condition. Yeah, so the code is looking fine. Let's compile it. So compilation completed. Let's submit the code. So our code is running absolutely fine. If you like the video, please share with your friends and subscribe my channel. Let's meet in the next video.